how many years does a medical doctor need before you'd say, she's an experienced doctor? How many years? 3, 5, 10? 10? You come into your doctor's office and there's a new doctor and they say that we have yeah, I'm this and that and I have 6 years of experience. Would you think to yourself, yeah, that's an experienced doctor? Or would you be like, maybe a bit young? Another question, how many programmers were there in the 1940s? 1, 2, Alan Turing plus a couple of his colleagues, maybe some people around the world. But today we have 20 million programmers. So how do you get from a couple to 20 million in a span of 60, 70 years? You have to double every 3 to 4 years, which means that our industry is stuck in perpetual juniorness. Because if the population of programmers doubles every 4 years, and we said that for experience we expect someone to have 5 to 10 years of experience, that means half of the people in our industry by definition are inexperienced, are juniors. So that we shouldn't write our code in a way where we expect that the person working on the code after us is going to be experienced, because there's at least 50-50 chance that there won't be. And we shouldn't write our code in a way where we expect the person after us to have a ton of skills, because in a lot of the cases they simply won't. But really we shouldn't write our code in a way where we expect the next person to be perfectly disciplined, to obey all the rules and do things right, because that person will in a lot of cases be us in the future, possibly in a hurry, under stress, and throwing discipline out of the window. The concept is nothing new. We learned it in the past decade with unit testing. There's a bunch of posts and online from the 2008 and those years around, where people are asking themselves, does testing make sense? Like, should we write unit tests? And there's a lot of people saying that we shouldn't, because tests are not flexible. They slow you down. You have to write, you have to write them, and that slows you down. And after about 10 years, we kind of learned as a community that is not true. That tests, that what we do in our day-to-day jobs, a lot of the times is just, or most of the times, is just rewrites and refactors. And tests enable refactors because they give you confidence to touch the code that you haven't seen in a couple of months or maybe a couple of years. And with tests, you have that confidence to actually move the code base forward and not be afraid that you will break things in random places. So here's a hypothesis. Types are the unit tests of the coming decade. Not in the sense that they replace unit tests. I still am very much enthusiastic about tests. I try to keep 100% test coverage with everything I do. But in a sense that people say today about types what they used to say about tests 10 years ago, that they're slow, that they're flexible, and that they kill productivity. I believe in a couple of years we'll learn, same as we did with unit tests, that types actually increase our productivity and bring it through the roof. But enough with the preaching. Let's look at some code. That's why we're here. We're going to say we're building an ancestry app, a competitor to 23andMe. And we're a startup, so we need to ship. We're in a hurry. We've defined this model, which is a class for a person that has a name and some parents. And now, we need some good data to have our dummy data when we're developing. So we need. I need help finding a famous family, possibly fictional, where everybody knows what the family tree looks like. Anyone has any ideas? Maybe somewhere where it's really important who the father is. So we modeled the Star Wars family tree with our person objects, and we're disciplined and good developers, good engineers, and we write tests for our code. We make sure that the init method works fine, and we can get the name, and then we can get the grandparents. And this is our entire code now. I split it in 3. It's a single file. You can get it on GitHub. I split it in 3 so it fits on the screen. Yeah, and Let's run the tests. Okay. So all passed, 100% test coverage. And then a user comes and we get an error. How could this be? Like, we have 100% test coverage. Like, we're perfectly, like, we're disciplined developers. What's going on? And non-type object has an attribute mother. Fine. This is the error up there. Oh, cool. You don't see this. Awesome. I have to do this and this again. Welcome to the billion-dollar mistake. This is Tony Hoare. He developed Algol, which was the first object-oriented language. And he said while developing Algol, also Python is a descendant of Algol, his goal was to ensure that all the references should be safe and that the compiler would check the references, but that he just couldn't resist the temptation to put in a null reference, which is a none in Python world, because it was so easy to implement, and that this decision, or this lack of a decision, led to innumerable errors, vulnerabilities, and system damage and crashes that has probably cost billions of dollars of damage in the past 50 years. However, with Python 3.5, there's a new core library called typing, and we can use this library to document the types of attributes and parameters. For example, we can say up there that the person class has two attributes, a mother and a father, and they have to be instances of the person class, or they can be none. This is what the optional gives you. So it can be whatever is in the brackets of the person or none. So this is now our new code. So you can see in yellow the changes that I did, and we can run mypy again. Oh yeah, not again. We can run mypy, which is the tool that can read this information, this documentation about types, and then try to understand what your code does, and then give you hints saying like maybe there's something wrong there. And sure enough, mypy tells us that in the grandparents where we're appending down here, we do self-mother.mother, and we said that a mother can be a person object or it can be a none. So in some cases we have basically we're calling none.mother, and you cannot, none has no attributes, so that's why our code fails. So mypy uncovered a bug that our tests didn't, even though we have 100% test coverage. And informed by the warning that mypy gave us, we can fix the bug before it gets to production, and we can also then make the tests better, so to make sure this doesn't happen again. We run it in production again. No, first we do some tests. Yeah, still. And now we can go to production. And another user comes by and wants to get Kylo Ren's grandparents. And I'm not sure if this bug is now worse than before or not, because like the first bug, you see it in your error logs, you see maybe you get a report in Sentry, maybe you get an email, like the thing crashes, but this one can go unnoticed for weeks, months. And let's see how we can prevent it with using typing. It's very simple. We just, besides documenting attributes and parameters, typing also allows us to document return values of methods. So we say that the grandparents method should return a list of persons, because a grandparent is a person and not something else. So this is the changes to the code, nothing else. We can run mypy again, and gives us a new error or a new warning. It says that we have an incompatible return type, that mypy realized that our grandparents method returns a list of persons and none. And we said that up here in yellow that it should return just a list of persons. And then we know, oh yeah, it's because self-mother.mother, so the second mother can be none, and in that case we're returning a none. And that's a bug in our code. So we fixed the code by just discarding all the nuns before we return. And we also fix the test because now we know that there's another edge case that we can cover. Because this is the problem with unit tests. A lot of the times, in your mind, you only think about the happy path, how the code should run, and you write tests for that. It's really hard to figure out all the possible edge cases. And you have to be super disciplined to really catch all the possible edge cases that you can then write tests for. And MyPy helps you to discover some of those edge cases. Obviously, it's not going to catch all, but if you can have a script that runs in a second or two, in a couple of seconds, and check that you've caught all the edge cases, that's super good. You run your app in production, and you get an email that like super nice, they want to use it. Your CTO wants to use it in their REST API framework, and that all these objects need to implement a .json attribute to so that they can use it because the REST API returns JSON. It's very simple. We just add a new method called JSON and returns a name. Add a test because we're disciplined developers. All the tests pass. Good, and it's in production. We get another email like, this is really good, but I want to optimize the amount of API requests I'm sending to the backend, and I want to get the names of parents like with additional requests. Why don't you just include the parents' information in the request itself, in the response itself? And like, yeah, that makes sense. Let's do it. So besides the name, we say we just add the mother and the father. We again fix the tests. We run them. Still, all the tests pass, 100% test coverage. We push to production. And a user comes and says that they want a JSON for Luke Skywalker. Boom, again. And this one, it's a different, like, it's not something with none. It's object of type person is not JSON serializable. And let's see if we can fix it with types, or if MyPy could catch this. You will notice that we were not actually really disciplined developers because we forgot to add the return documentation. And when we do, we say that this JSON method will return a dictionary that will have, for keys, it will have strings, and for values, it's going to have strings or none. Nothing else changed, just this type information. And we run MyPy again. And again, we get a new warning from MyPy. So because we gave MyPy more documentation about what our code should do, it can guess more things about what our code really does, and that tells them that if these two information are not equal. So what in this case MyPy tells us that we're giving so our method, JSON, returns none or person object, but we're saying it should return none or a string. And these two don't match. And then you start look at the code and like, of course, it should be selfmother.name because that's a string and JSON returns like it needs to be a string. But just before you push to production, you run MyPy again, and there's another warning. Well, sometimes MyPy will know that self-mother can also be a none because you said it can be a none, and actually you cannot call .name on a none, so that would fail if you would push to production. And then you finally fix it the way you should, like if mother exists, only then call .name. And you look at the code and you're like, are there more documentation that is missing and I'm not disciplined enough to realize where they are? And can we stop relying on being disciplined? Well, yes, we can. We can call MyPy with -- strict. And it's going to tell us all the parameters, arguments, and functions that don't have proper type documentation. And we run through them, and this is the end result. This is our code fully typed. There's not a lot of extra characters. It's not like when you use types, your code is going to look massively different. It's very slight differences. And also, these types are completely ignored at runtime, so there's absolutely no performance impact. And they're very handy for the person the next person reading it, because it's basically the same as having docstrings, writing docstrings, but then having a butler making sure that all the docstrings are always up to date. That butler is called MyPy. And also your IDE, your code editor, uses this information to give you more and better suggestions when you write code. Like I said, having types is like having always up-to-date and up-to-conventions doc strings. In Plone API, we agreed we'll document function parameters using the autodoc approach. And so the line above generates documentation like this in docs.plone.org. And we basically relied on every contributor being a disciplined engineer that will not forget to document the return value. And sure enough, after 5 minutes of browsing Plone API code, I found a function that is missing the return declaration. And it's also missing in the documentation as a consequence. And nobody across 60 contributors over the span of 6 years noticed this. And today, bugs like this are completely preventable using MyPy, because MyPy will alert us if we use the -- strict option that we haven't documented or properly documented the return time. Side note, it's been 6 years since Plone API. Damn, I'm old. But the mess can be way bigger than just missing documentation. A recent paper shows that 1 in 5 genetic papers contains errors because Excel converted gene names to dates. The amount of scientific hours that are rendered completely useless because of a typing mistake. Come on. And Airbnb said that in a recent post-mortem analysis, they found that 38% of the bugs that they surfaced into their production could have been prevented by using types. And you always, that the earlier you catch a type, the cheaper it is to fix it. And MyPy and similar type checkers run way faster than your tests. So you don't have to wait 10, 15 minutes for your test to tell you that you have a bug in your code. Like you can wait 10 seconds, 15 seconds for MyPy to tell you exactly the same thing. And there's even a paper showing that typing does discover bugs. So what these people did was they took public JavaScript repositories and then they found commits that fixed bugs and then reverted those commits and introduced types and then run the type checker. And they found out that the type checker could find 15% of bugs that went all the way through testing, QA, into like production repositories of public JavaScript repositories. And it's like just using a couple more characters in the code saves you 15% of public bugs. It's insane. And finally, just to give you a bit more food for thought, there's a recent blog post from the creator of MyPy showing how Dropbox went to type checking 4 million lines of Python. And they also said that without type checks, they could never have been able to migrate from Python 2 to Python 3. And by the way, Guido van Rossum is employed by Dropbox, and he's working on MyPy. So MyPy is not some obscure thing on the edges of the Python ecosystem. It's almost as core as it gets. And sure, this all looks fine, but you might ask yourself, where to go from here? Well, start using MyPy today. It's very easy to install, and just add it to your CI and see if there's warnings that make sense, and start learning about it. Additionally, there's all this talk about Plone, like Plone, what Plone is today, and Plone today is an API, but there doesn't exist a document that describes this API. That's strange, and one possible way to do it is OpenAPI, which is basically types for your APIs, for REST APIs. And I'm giving a talk about OpenAPI on Friday, so welcome to that. And finally, start playing with Elm. Elm is a very delightful front-end language, so it's just for front-end. It compiles to JavaScript, and it's strongly typed, so it will not compile unless you do the types right. And it will absolutely change the way you write your Python code, because you learn to recognize like whole new classes of bugs and avoid them. And also you will understand MyPy way better. And MyPy is becoming increasingly more prevalent at least in modern Python development. Thank you.
You, Nejc. Somebody have some question? Okay.
Hello.
Hey,
Do you know which is the logical theory behind the typing library? I mean, the power as a logical theory. What does it check? Is there some, I don't know, research paper? Do you know more the internals of that?
I don't know the internals,
Okay.
but like the guy that created it came straight from university, and if I remember correctly, like he's a Haskell, like he knows Haskell, and Haskell uses Henry Miller's type system. So I think it was inspired by that, but I wouldn't know for sure.
Okay, thank you.
Other question? Okay.
Hi, Nick. One of the nice things we do have in Zope and Plone is interfaces, because interfaces also allow you to describe things. Python itself is more going into the direction of protocols. And is there also a way or an idea how to make a description that your class following a protocol in that way?
So yeah, protocol is, you know, basic. You could say that it's a re-implementation of Zope interface in the modern Python, and I don't think they're mutually exclusive. There's a MyPy extension for Zope interface, and protocols are a very new thing. We're not sure if they're going to stay around in the current implementation. So yeah, just they can both live side by side for a few years, easily.